complimentary indeed, and we're looking forward to the next steps. Yeah.
And I'm wondering, did James somehow drop off? Because I think now Daniel Ruiz Carrasco next. Or was it Elisa? I can't remember.
Daniel, how's your voice? Okay, maybe I can have my talk first, and if James come back, he will probably help Daniel in running his talk, or I can do that. James doesn't come.
Lisa, go ahead, because I think we lost James, which is of course very bad. But yeah, let's go on with the show.
Yeah.
Go ahead, Lisa.
Yes. Yes. Okay. I think, do you see my screen? If not, please tell me. Good. This talk is about, another topic related to mountain climate change, of course. My name is Elisa Palazzi. I work at the University of Turin, but I'm also co-lead of the GEO Mountains Initiative. And I'm very glad to present this talk on elevation-dependent warming, so the stratification of warming rates with the elevation in the Andes. And the aim of the study was twofold, and we published, if you are interested, in the cited papers here in this slide. And I was saying the aim was twofold. One aim was to assess and characterize the elevation-dependent warming signal in the Andes, trying to found the dependence on the latitude, on the season, and on the side of the Cordillera. And the second aim was to disentangle, in a way, the several mechanisms play in shaping the stratification of warming rates with the elevation. This was a study using climate models. We looked at the future changes in elevation-dependent warming. So we used a small ensemble of climate models, actually one regional climate model called RCA4, driven by 8 different global climate models of different resolutions. The regional climate model was run within the Cordex experiment at 50-kilometer resolution. In the right part of this slide, you can see a comparison between the elevational distribution in the regional climate model in blue and compared with a high-resolution digital elevation model in pink. And of course, as you can see, and as expected, the climate model underestimate the highest elevations, and we of course asked whether this bias could lead to some problems in correctly reproducing the climatology of the area, and we tested this just comparing the snow at ground and the temperature with some observational